Okay, here I just copied a couple things from above. I'm going to walk through this example. So I had ty prime minus y equals t squared e to the negative t. I normalized it. We did that already. That gives me t minus 1 over ty equals t. Because when I normalize, I got to divide everything by this guy right here. So the t squared goes down to a t times e to the negative t. I also rewrote our formula for mu, which is our integrating factor, which is e to the integral of p of t dt. So in this example right here, that is p of t. So let's rock it because it is amazing. All right, so I need to figure out what my integrating factor is. So let me flip the page here. All right, p of t equals 1 over t. So mu is e to the integral of p of t dt, which in this case is e to the integral of 1 over t dt. I look at this. This is perfect. I made or started to make, but caught it, a classic, and this is the mistake that everyone makes. Do you see what I did wrong? If I go up here, when I worked out all this product rule, there was a plus sign right there. So if there is a negative or something like that right out front of that thing, I need to include that. So this is good that this mistake happened because you guys will all make it. This whole thing here is the p of t. So there's a negative there. So do not miss that because it just throws everything off. And usually, this is usually if you do this, you will often get stuck doing some terrible integration by parts. And it will be wrong anyway. All right, so e to the integral of negative 1 over t dt. So that is e to the integral of negative ln of t, absolute value. I do not do a plus c here. I could explain it to you and convince you, but I'm not going to do that right now. Maybe I will do that at some point later. So we don't need to do a plus c. And I can 100% totally convince you, but I'm not going to address it right now. So if I need to, oh, come on, man. That's what it is. So I already integrated. That's where I got the ln. So this is like not in a good form. But, ooh, I got an e and I got an ln. I want to try to cancel them. But I can't because of this negative. The negative's in the way. Negative. But remember our plug rule? P log of x is x log, is log of x to the p. So I can plug this thing. This p out front is negative 1. So that negative 1 can move inside the ln and become an exponent on the t. So that gives me e to the ln. I'm going to just get rid of the absolute values because I can. Well, I guess I'll leave them. Absolute value of t to the negative 1, which is, I'm going to do two things at once here. No, I'll do it all. E to the ln absolute value of 1 over t, which now the e to the and the ln are going to cancel, and this just gives me 1 over t. So this is my mu. That is what I need to multiply by, right? Because remember, if we come all the way up here, I needed to multiply by a function, mu of t, that we call an integrating factor. I need mu to make the left-hand side product roll backwards. So notice everything here gets multiplied by mu. And this is where it's like, whoa. So I'm multiplying this by mu. Make sure. Okay. So I'm going to go and multiply by 1 over t, because that's my mu. That gives me 1 over t y prime minus 1 over t squared. That doesn't look good. I don't like that. T squared y equals, oh, look, it works out great on the right side, e to the negative t. Now, look at that for a moment and think about what we started with way up at the top, way up here. That's not going to let me go. Whatever. Come on. Think about all that product rule backwards that we did. It's right there. That's what it is. Look. This guy. Oops. This guy derives or is the derivative of that guy. And then clearly my y derives to this. So I get my same dir and dir, right? And actually I should probably, if I'm going to do this right, I should include this negative, because that is part of that, right? The derivative of 1 over t is power rule, right? It gives me negative 1 over t squared. The derivative of y is y prime. So it's perfect. What I can do now is write this as, I'm not going to integrate yet, but I want you to see that this mess, this left-hand side mess, is really just 1 over t times y primed, right? This prime, derived with respect to time, is this thing up here. And that is equal to e to the negative t. And back to basic calculus logic, integrals, derivatives, opposites. So now I can integrate that. If I do it to one side, I do it to the other side. What's this integral going to do? It's going to cancel out with that derivative. And I know how to integrate this right-hand side. So I get 1 over t y is equal to, what's e to the negative t integrate to? Negative e to the negative t. Now, I said earlier that dropping that negative is the fatal error spot, right? That's a spot where you can jack up the problem. This is the next spot where people are most commonly make mistakes, and that is to forget your plus c. A lot of times people, when they take calculus, get in the habit of forgetting the plus c and then just throwing it in there at the end. I can't do that here. I got to do it at this step. You'll see why. So remember, I want a solution to y, or I want to solve for y. I want y equals, so I got to multiply by t everywhere. That gives me y equals, I'm going to switch the order of these because I like it not having that negative first, but I get c times t minus minus t times e to the negative t. If I had forgotten my plus c and did my multiplication and then just threw the c in, then the c would not be on this thing and it wouldn't be the solution. So this is the solution to my original equation, which was ty prime minus y equals t squared times e to the negative t. It would fit perfectly. What I mean by that is, in our last class, we talked about what it means to be a solution to a differential equation. And I actually encourage you to test this, right? Because you may not believe me. You'd be like, okay, yeah, whatever, right? But do it, right? Take the derivative of this, multiply it by t, then subtract the original function. Bam, you're going to get this guy out. So that is all. And we will do some practice problems with this when I see you next. And thank you. And come if you have questions about anything that I did here, please come to class with that and I will address that. I will also post a PDF of this entire page right here on our drive. Thank you. See ya.